Hi, today I would like to explain about the infinite intervals of integration. We have explained some more ideas about improper integrals, and this improper integral is exists if the interval of integration is infinite or f is unbounded. Then we say that the integral is indefinite integral or improper integral. Okay, so infinite intervals of integration in this we have explained it before. Improper integral with infinity limits of integration. How to integrate this one? Integral from a to infinity f of x dx equal to limit b tends to infinity integral from a to b f of x dx, provided that limit exists. We have explained this before, and we have done this example also. Okay, and this example, listen this example, find the values of p for which integral 1 to infinity 1 by x raised to p dx is convergent. Convergent means limit exists. Okay, so from this integral from 1 to infinity can be written as limit b tends to infinity 1 to b. We have to convert this indefinite integral into a definite integral, that is using the limit concept. So limit b tends to infinity, taking the limit of x raised to minus p means x raised to minus p plus 1 divided by minus p plus 1, that from 1 to b, that's equal to 1 by 1 minus p, limit b tends to infinity 1 by b raised to p minus 1 minus 1. So if p less than 1, then 1 minus p is greater than 0. Limit b tends to infinity 1 by b raised to p minus 1 equal to limit b tends to infinity b raised to 1 minus p, which is equal to infinity. Therefore, the integral diverges. If p is greater than 1, then p minus 1 is greater than 0. So, limit b tends to infinity 1 by b raised to p minus 1 equal to 0. Okay, that's equal to 0. This also the answer is, this is 1 by p minus 1 if p greater than 1. That means it converges and converges to the value 1 by p minus 1 when p is greater than 1. Otherwise, the integral diverges. Similarly, evaluate this problem. This is e raised to minus x, integral limit b tends to infinity minus 1 to b e raised to minus x dx, that's equal to limit b tends to infinity e raised to minus x from minus 1 to b, which is equal to limit b tends to infinity e raised to minus b plus e raised to t, which is equal to e, that is b tends to infinity means e raised to minus infinity, that's equal to 0. So this is e raised to 1, this is equal to e. Second is 0 to infinity cos x dx, that's equal to limit b tends to infinity integral from 0 to b cos x dx, which is equal to limit b tends to infinity sin x from 0 to b, that is sin b minus 0, that is b tends to infinity sin b minus 0. Since the limit b tends to infinity sin b does not exist, we conclude that the given integral is divergent because the limit does not exist. Consider this example. Evaluate integral from minus infinity to 0 x e raised to minus x dx. Okay, so in this first we have to convert this into a definite integral. So I am considering the example, take the concept of limit here. Limit a tends to infinity integral from a to 0 x e raised to x dx. So we have this equal to x e raised to x minus integral of derivative of x into integral of e raised to x, that is integral e raised to x dx, that's equal to x minus 1 into e raised to x plus c. minus infinity to 0 x e raised to x dx equal to limit a tends to minus infinity integral from a to 0. This equal to limit a tends to minus infinity x minus 1 into e raised to x. That's equal to a tends to minus infinity. That's equal to minus 1. This equal to minus 1 minus a minus 1 raised to e raised to a. So letting a tends to minus infinity, so this term will get cancelled. That will be 0. Okay, so minus 1 is remaining term in this. Then what will be this one? A raised to a. In this, how it will become 0 here? A into e raised to a minus 1 into e raised to a. This equal to a by e raised to minus a. That will be of the form 0 by infinity form. So limit a tends to infinity minus infinity. I'll use the L'Hopital's rule. 1 by minus e raised to minus a, which is equal to 0. So limit a tends to minus infinity. This term get cancelled. That will be 0. The only term is minus 1. So the answer is minus 1. Is it clear? First to take the derivative. First to convert this into a definite integral by using the limit concept. Then next to integrate this. Put the limit value and letting limit apply the limit. Okay, so this is a procedure actually. So evaluate next minus infinity to infinity 1 by 1 plus x square dx. Evaluate this and interpret your result geometrically. Here the look this example. Here the limit is minus infinity to infinity. That is minus infinity comes in two places, that is from first and last. So minus infinity to, we have to split this into two. Minus infinity to 0 1 by 1 plus x square dx plus in 0 to infinity 1 by 1 plus x square dx. Limit a tends to minus infinity integral from a to 0 1 by 1 plus x square dx plus limit b tends to infinity 0 to b 1 by 1 plus x square dx. So limit a tends to minus infinity tan inverse x from a to 0. This equal to tan inverse x from a to 0. Here this is tan inverse x from 0 to b. Letting a and b, a tends to minus infinity, b tends to infinity. So this is tan inverse 0 minus tan inverse a. This is tan inverse b minus tan inverse 0. Tan inverse 0 0. Tan inverse a means tan inverse minus infinity. That will be minus pi by 2 plus here this is tan inverse infinity, that is pi by 2 minus tan inverse 0 is 0. So the answer is pi by 2. This is minus of minus pi by 2 plus pi by 2, that's equal to pi. Next example, a rocket launch. Find the work done in launching a rocket weighing p pounds, verifying vertically upward from the surface of Earth so that the rocket completely escapes the Earth's gravitational field. Okay. First attempt is we have to evaluate what will be the integrand in this question. We have to evaluate work done, that is we have to evaluate the force that's equal to gravitational field gm capital M divided by h square. M is the mass of rocket, capital M is the mass of the earth, x is the distance between the rocket and center of earth, g is the universal gravitational constant. So f of x equal to k divided by x square. This is the function. Evaluate this. Okay. Do it please, and if you have any doubt, please ask me. Okay. Next, we are going to explain about improper integrals with the infinite discontinuities. Improper integral with the infinite discontinuity. One by root x. Here 1 by root x, consider the graph of this one. So this have at x equal to 0, this have infinite discontinuity. So we can discuss the further things in the next video. Okay, thank you.